Dear students of Vocational Training Diploma on Electrical and Hybrid Vehicles, I am Engineer Mohammed Masad from University of Jordan, member of EcoCar Committee. Under the Erasmus Plus project, which is coordinated by University of Jordan. Still, we continue our cluster number 5 about basic of electricity and electronics, and we will continue in topic number 4 of cluster number 5, which is about automotive electrical circuit. The duration of this third lecture of topic number 4 that will be about 48 minutes, and it will cover the following subjects. Now, fuse protection device, the definition of electrical fuse, electrical fuse is a protection device which is considered to be one of the basic components of the electrical circuits to protect the electrical circuit from excessive current by cutting off the power and interrupt the current path flows from damage if current levels exceed a protective level. So this fuse is a protection device to protect the circuit from excessive of current. The importance of vehicles fuses. Vehicle fuses are used for the following: to protect all internal or external vehicle systems and devices from being damaged that may stop the vehicle. Fuses are rated according to how many amps they can handle before the fuse blows and stops the flow of current through the circuit. A blown fuse indicates of an overhead circuit or a fault such as a short that is causing excessive current flow in the circuit. If something electrical in your vehicle stops working, the first thing you should check for is a blown fuse. This is the shape of vehicle fuse that you can see in your vehicles. This is about 15 amps that will be discussed next slides. The location of vehicles fuses. The vehicles fuses are located in two fuse boxes. The first one, underhood fuse box, is in the engine compartment next to the battery, as you will see in this picture. This is in the front of the vehicles. It's called the engine compartment, and here is the battery, and this is the fuse box, and this is the engine. The second location is interior fuse box is underneath the steering column inside the vehicle, near here to the left leg of the driver, near the steering. This is the interior fuse box inside the car. Types of fuses. There are many types of fuses, such as blade type fuses, standard size, mini size, maxi size, mega size, fusible links, circuit breakers, ceramic EV fuses, cartridge fuses. So here, many kinds of fuses. This is also ceramic fuses. We have here EV fuses. Most of the vehicles use like these kind of fuses. Types of fuses. The first one is called blade fuses. used in most automobiles, like this figure, which have different colors and amps of blade fuses. It has six kinds of shapes and colors. First one, second, third, fourth, fifth, sixth. This is the plastic side of the fuse. This is the pins used to put in the sockets inside the fuse box. Uh, this plate fuses, also called plug-in fuses, due to these pins. Plastic body, the plastic, with rated current. We have here the rated current of these kind of fuses, depends on the color, with in amps on the top. So see here in the top. This these types of fuses come in six different dimensions, as we said before. So it depends on the application, depends on the system, depends on the circuits. We can use these kind of blade fuses. The second type of the fuses, which is called standard and mini fuses, like these shapes, it's called standard fuses, from 15 to 5 amps, from 30 to 20. So high values of current here. Second types for the mini fuses, small shapes, the same colors. For example, the yellow one 20 amps, also this is 120 amps. The blue one 15, 15. The green one 30, 30. 7.5, 7.5. So the same rating of current as different shapes and sizes. Fuses come in different colors, as you see, shapes, different size, from 1 amps to 100 amps. This is a table shows many different colors and amps of standard and mini fuses. This is the fuse amps rating and identification color. Violet, 3 amps, 5 amps tan, 7.5 brown, 10 red, see red, 15 yellow, sorry, blue, 20 is yellow, 25 colorless, and 3 amps green. So this is different kind of colors and amperes of standard and mini fuses. Third types of fuses, which is called maxi fuses. As you see here in this picture, there are many different kinds of shapes and colors on different amps. This is also a table to show the color and amperes of maxi vehicles fuses. This is the fuse ampere rating from 20 to 80 amps, and advantage color yellow, green, and colorless. For example, 80. This one is 80 colorless color. This is, for example, yellow maxi fuses with 20 amps. For example, this one is about 60 amperes. The blue one. So this is maxi fuses used in vehicles. The fourth types of fuses, which is called mega fuses, like this shape, is about 20 to 125 amps. Mega fuses are ball downstream fuses that are used to protect high current circuits in the vehicles. If mega fuse blew, the car would not operate at all, so it is dead. These mega fuses are offered in 100 to 50 amps, so this kind of fuses is about 250 amps. And here the shape of the vehicles near the fuse box. We have here the mega fuse about 100 amps to protect all the systems in the car. So if this one is blue, so the car would not operate at all. The fifth types of fuses is called fusible links. Fusible links are used to protect circuits between the battery and the fuse block. Generally, circuits 3 amps or more. This is the shape of the fusible links used in vehicles. Fusible link, its function is to open electrical circuit when overloaded. Nowadays, vehicles use maxi fuses instead of fusible links. Fusible links usually located near or in relay fuse boxes in the engine compartment to feed current to the fuse box. As you see here in the vehicles, this is the fuse box or fuse box and relays. We have here the fusible link to protect the high current and also to feed the current also to the fuse box. The fifth types of fuses, which are called the circuit breakers. Circuit breakers are used in place of fuses to protect electrical circuits such as the power windows, sunroofs, and heater circuits. Circuit breakers provide overload protection and prevent current spikes from reaching the damaging sensitive electronic components and prevent electrical fires. They are located near relay fuse box in vehicles, such as this shape. This has circuit breakers about, see here, the battery. We have here the positive cables, and this is a circuit breakers with a rate of 100 amperes, and this is a waterproof device. The seventh part or types of fuses, which are the ceramic EV fuses, electric vehicles fuses. This is about 800 volt DC, 6 to 600 amps. This is automotive fuse for EV, high voltage and better protection, high speed power fuses. This shape is different kinds of ceramic EV fuses with different size, with different rates, 500, but there is a difference in the current. This is 20 kilo amps, 20, so different sizes. Voltage 500 DC, current ratings 50 to 400 amps, and we have here a box for the high voltage, since we have here color orange colors, so we have here different sizes of EV fuses. Another type of high voltage protection devices, such as service plug grid, which is an electrical protection device with main fuse 125 amps, can be used in the high voltage system to provide all the components in this system. This is a shape of high voltage fuse from ceramic. The rating of this is about 125 amps. Okay, this is might be used inside the service plug grip and other types of Toyota Prius vehicles. So this is service plug grip in the Prius. The reasons of blowing fuses. There are many reasons for the damaging of fuses. This is good fuse. This is a blown fuse. So we have here cutting in this area here. So this one is good, and this is blown fuse. What's the reason of blowing fuses? The passage of high electric current instead of it's supposed to pass, which is called the amps rating. The amp rating of the fuse is labeled on the plastic side or part of the fuse, and this occurs as a result of a shortage in the electrical circuit or a high current in the circuit. The most common cause of a blown fuse is when something draws too much power from the circuit. This is the most often caused by either too many loads or from using too many plugs in circuits at once. Vehicles fuse boxes. Vehicle fuse boxes are one of the most important parts of the vehicle. They contain fuses, circuit breakers, and relays. which are necessary to operate the vehicles. They are usually located inside the vehicle in the following locations: the vehicle's driving room, in or around the instrument panel near the dash. Still we are in the driving room. Behind the left or right kick panels or under the dash, under the left side of the panel, under the hood in the engine compartment, which is external a part of the vehicle, under the rear seat. Still we are in the vehicle's fuse boxes. As we said before, there is many locations for the vehicle's fuse boxes inside or outside the driving room. The first location is in the engine compartment. We have also a fuse box, or maybe two boxes, one for fuses and one for relays. This location are usually grouped together and are often mixed in the other components like relays, circuit breakers, and fuse elements. These fuses are located inside the vehicle engine and near its battery, where the fuse box contains the most important parts related to the car. This is a view of engine compartment fuse box. A lot of fuses with different size, with different colors. This is relays. Okay, this is engine compartment fuse box. Another shape is like this. This is here fuse box, and we have and there is a relay box. This one you can see in Toyota Prius 2004, 2009. These locations for fuse boxes. The importance of fuses in the engine compartment. These fuses are located inside the car engine and near its battery, where the fuse box contains the most important parts related to the car. And usually they are protect the following systems: car fuel control, air conditioning control, control of the safety airbag, controls the start of the vehicle, and other various important fuses in the vehicles. Dear students of vocational training diploma, you are welcome again in a new lecture of Cluster 5 of Basic of Electricity and Electronics. We will talk about part 8 of chapter 2 of topic number 4 about the main components of automotive electrical circuits. I am Engineer Mohammed Masad. You are welcome again in the division of automotive loads, which is our lecture today. Electrical loads are working devices like lamps, motors, where are one of the important components of the electrical automotive circuits. They are consuming power during the flow of current in the circuit, and in turn this power changes into electrical energy or mechanical energy to perform work. Each load has its resistances that can be measured in using ohm meter. Automotive circuit with load. This is shape of electrical circuit used in vehicles. This is the load. Any device in vehicles such as lamps, horns, wiper, motor, or rear windows before that consumes electricity is called a load. So this is one kind of load is called horn, this load consumes energy. In this circuit, we have here a protection device called the fuse, for example, and this is a control device, as we said before, switch, and we have here the power source, which is a battery of 12 volt DC. In an electrical circuit like this, all loads are regarded as resistance. So we have here inside a resistance inside this load. Loads use up voltage from the power source and used to control the amount of current flowing in a circuit. Loads with high resistance causes less current to flow, while those with lower resistance allow high current rates to flow. So when these loads has high resistance, this will cause less current to flow inside this circuit. But when they have lower resistance, they will allow high current rates to flow. Types of loads in vehicle, or you can say types of automotive loads. The load device is actually puts the power to work and is the visible indication of what the electricity actually does. They are classified into the following types: resistive loads that consumes power, such as lamps and heating elements that has internal resistance inside these loads. For example, this is automotive lamps. Capacitive loads, such as capacitor that use in alternators to store electrical energy power, such as this kind of capacitors is called electrolytic capacitor. And also this one will be also discussed in another slides. Inductive loads that use coils in devices such as motors, transformers, relays, that stores energy in a magnetic field when electric current flows through it, like this shape of inductive loads. This is wires, okay. Now continue with automotive loads that are working by power supply 12 volt DC from the battery. The electrical loads in vehicles can be classified and distributed according to their operating conditions as shown in the figure. This is the figure which shows many of 12 volt loads. These loads use a negative terminal which is connected to the chassis. So all of these loads, one of their sides are connected to the negative battery, so the negative battery, which is connecting to the frame or the chassis of the vehicle. The other part or side of the vehicles are connected to the positive terminal of the battery of 12 volt DC. So for example, there is a horn. This is connected to the fuse box, and the current comes from the positive side. And the other side of the vehicles connected to the negative or to the chassis. This is also headlights, front headlights. They are connected in parallel and connected to the fuse box and then to the positive sides. And also we have here flashers and parking lights, also in parallel, connected to the fuse box and then to the positive terminal of 12 volt. Another example also, we have here spark plugs and distributor and ignition coil. They have uh, a fuse in the side the fuse box and connecting to the positive terminal of the 12 volt. Also we have here a starter. It's directly connecting to the positive side. And also there the alternator and the regulators also connected directly to the positive side, not during the fuse box, maybe connecting during fusible links or something like that outside the fuse box, because it's a consume high current. Also, the Whipper here also has a special fuse connecting to the positive terminal. Finally, switches also has special fuses inside the fuse box connected to the positive terminals. Car radio and accessories also has special fuses here with positive side. Room lamp also have special fuse connected to the positive side. Go to the rear side of the cars. Tail lights, brake lights, they are parallel and they are connecting to the fuse box. And also the flashers and parking lights, this one and this one, also connecting in parallel and goes to the special fuse to the positive side. So in general speaking, we can say that all the loads have two terminals. One is positive, connecting to the positive terminal during the fuse box, and the other side connecting directly to the chassis of the vehicles, which is in turn connecting to the negative side of the battery. Let's see different photos of automotive loads. First one, this is heated car seat. This is resistive load. Solenoid, door lock, cooling fan, electrical mirror, one screen wipers, ignition coil, horn, lamps. Dear student of vocational training diploma, you are welcome in a new lecture, which is the fourth lecture, and also the final lecture about cluster 5 of basic of electricity and electronics. That will be talk about chapter number 3 of topic number 4 about main components of automotive electrical circuits. I am engineer Muhammad Nasser. This chapter number 3 will give an information about electrical schematic and electrical diagrams, showing and explaining how to read and interpret the symbols on diagrams and describe the layouts of electrical diagrams. This chapter will cover the vehicle wiring diagrams, types, concept of operation, and some examples of diagrams and the main components of diagram symbols, lines, and colors. Concept of electrical diagrams. Electrical diagrams are drawings which are used to represent electrical circuits that can be found in service manuals of automotive manufacturers. These manuals include wiring schematics of every circuit in the vehicles, and the circuits are represented by using lines, symbols, and number combinations and wiring. A wiring schematic, sometimes called a diagram, shows electrical components and wiring using symbols and lines to represent components and wiring. Definition of electrical circuit. Electric circuit, as shown below, it's a closed circuit when the switch is closed, consisting of wires and resistors. Wires and resistors with a specific resistance to allow current to flow. During connectors when the switch is on, during the load or the resistance, come back to the negative terminal of the power supply. So flows when connected between the terminal of a battery. Okay, this is the positive and the negative. It's represented by drawing circuit diagram. So this is a symbol of circuit diagrams of electrical circuit. Main components of circuit diagrams. A circuit diagram, wiring diagram, or electrical diagram is a graphical representation of an electrical circuit. It uses simple images of components. All circuit schematics or diagrams include the following parts: power side wiring of the circuit, connectors, wires, wire size, wire color, trace color, circuit number, electrical components, ground return paths, fuses, and switches. Main symbols of components in circuit diagrams. Circuit diagrams are drawn to understand the operation of a particular circuit. They use electrical symbols as shown in the table to identify various circuit components and the routes of the current. Symbols, this symbol is for wire, this is for lamp, this is wires or two wires. This one, when there's a dot with these two wires, is connected. This one also are connected like this, but in this shape is not connected, these wires. The shape of a fuse or symbol of a fuse. This is a symbol of resistance, fixed. This is symbol of a potentiometer or variable resistance. This is the rheostat. This is a symbol of cell or battery. This is a symbol of a switch. This symbol of a battery with two or many cells, or like this one. This is a shape or symbol of a voltmeter to measure the voltage, which connected in parallel, as we said before. And this is the ampere meter connecting in series in the circuit. So these symbols show all the different components in the system, including their interconnections between each. Block diagram. This is another kind of diagrams called block diagrams. Block diagrams or circuit diagrams are used to describe the sequence of circuit operations, give the user the overall view of the circuits by breaking them down into smaller blocks. Each block performs a particular function, and the block diagram shows how they are connected together. The figure shows the path sequence of input AC and output DC. We have here a block diagram of power supply. We have here blocks. There is an input, input is output. So input here is an AC input, and we have here an output of regulated DC output from the regulator, from the filter, from the rectifier, from the transformer, and this will, by the way, will be discussed in other slides about about the regulated DC power supply. Schematic diagram. Electric circuits are represented by a schematic diagram as shown in the figure. This is a figure of two different kind of circuits. This is, we call this one as a schematic diagram. This is actual circuits with components or circuit diagram. Schematic diagram is a graphical representation of an electric circuit with the standardized symbols, see here symbols, representing circuit components. Schematic diagram is used for troubleshooting because it's easy to understand the operation of the circuit. So we have here four components: battery, symbols of battery, bulbs, closed switch, wires, and we have here the same. What's called actual circuit to see actually the components. This is the battery, this is the symbol of battery. This is lamp, bulb or lamp, this is the symbol of lamp. This is a symbol of a switch, this is the actual switch, and this is the wire. So this is a circuit with power source to deliver current during the circuit. Also here is a closed circuit with many kinds of components. Definition of wiring diagram. A wiring diagram is the easiest to use for wiring and installation. It's sometimes difficult to understand circuit operation and is not as applicable for troubleshooting. This is a wiring diagram of horn wiring diagram. We show us the wires here between these components. So this is the horn of the load. This is the control device relay, the switch to control on and off the horn, and we have protection fuse. This is also ignition switch of the vehicle, and we have the power source also as a battery. A wiring diagram is drawn by using symbols to represent the devices of an electrical control panel, as we see in this figure. Components of wiring diagrams. The components used to build an electric circuit are represented in wiring diagrams with symbols. Depending on the manufacturer, different symbols are sometimes used to depict the same components as follows. This figure shows wiring diagrams between different components. These components, for example, power supply and ground. So we have here a power supply of battery with positive and negative terminals, and the ground. This is the ground here. This is the ground, 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 ground. Two different components. Wires and connections. So this is wires between the control devices and the battery power source, and also there is wires, another colors of wires between the loads and the control devices. We have here wires, and also here wires. We have, as you see here, in different gauges. This is 18. But for lights and the ground, use 2 to 14 gauge wires, and we give you some information in the lectures about the gauge wires. Also, power consuming devices loads, such as inductive loads, motors, and coils. We have here coils of the relays. We have inductive loads, motor and coils. We have also resistive loads, heaters and lights. So this is lights, This is resistive loads in the yellow colors. Also circuit boards terminals to show the connections between the control boards they have in the system. Color abbreviations of wires. Wiring diagram is used to identify the color of vehicle wires circuit information as shown in the table. So we have here a table of the abbreviations and the colors. Some vehicle manufacturers use letters to represent a wire color, like this: dark blue, light dark green. These two letters to identify the color. We can check the service manual to have more information for the color abbreviations used. Now, this is, for example, this is the abbreviations of the colors: red, black. This is the abbreviation BLK, violet, VIO, gray, GRY, brown, BRN, white, WHT, orange, ORN, green, GRN, dark green, DK green, yellow, YEL, and purple, PPL. So this is abbreviations for different colors we can see on the wiring diagrams. Let's take an example how to read circuit diagram. If we have a section like this, this is a section for wires. We have here a connection between this wire and this wire during this connector. We have here a wire without any connector. We have here the light or the load. Notice the following in this section. The wire color change at connection C-210. So there is a connection here between this wire and this wire. This wire is purple color with 0.8 size in square millimeter, 0.8 millimeter. Also with another wire, 0.8 millimeter. This color is purple white color, and this wire is 0.8 millimeter with black color. Example of wiring diagram. The figure, this figure, shows wiring diagram. You see in here wiring diagrams. Relatively out of the circuit components. This is component. This is the battery power source. This is the relay. We have here the loads and different colors of wires using the appropriate symbols and the wire connection. So we have here a fuse with 30 to 40 amps. We have here a relay with terminals, number of terminals, and the specification of this relay is 40 amps relay. We have here two loads, lights load. This is the connection, the size of the wire, 5.3 millimeter, and also this is the American wire gauges, is 10. And we have here the same size of this color. So this hot line, 5.3 millimeter in American wire gauge cable. Also we have here the ground with the black colors with the same size, 5.3 millimeter. So to pin 86 and to the loads. And also here we have a positive wire or a positive line, okay, to headlights being positive terminals to have a positive on the coil between terminal 85 and 186. But this positive line is coming during the isolation switch. So this wiring diagram shows the wiring between all the components. It shows the lines, the different lines with colors, different colors. These colors may be single or may be multiple conductors or wires that are represented and labeled with identifying number, this number here, and also the colors and color and the letter number combinations to more emphasize and clear how to read this wiring diagram to make some maintenance in this. Let's take also another example of diagrams. The figure shows a circuit diagram of controlling the operation of fuel pump with following function. This is a circuit diagram shows how to control the fuel pump by using relay. Is 4 pins, and also this, we have a controller or a computer how to control this pin with positive line. Power leaves the 12 battery positive through protection components fuse. So this line, positive line from the positive terminal of battery during this fuse goes to pin number 30. So if this switch of the relay is closed, so during this connector here with color of gray, this go to the positive side of the motor, and the negative side or ground side to the other side of the motor is directly connected here, so the fuel pump is working. But how to control this switch or this contact when this coil is energized? But when this is energized, when this side or this point goes to ground during ground black color here, and the other one needs a positive line from the controller during this connector, which color is dark and green, and dark green white. So in this case, when we have a positive signal from the controller, the switch here is closed and the pump is working. It looks for the shortest path to the ground side of the circuit during controller components. Relay pins 30, this is 30, and 87, as we discussed in other lectures about the relays. 87 connected directly to the load, so this is the load to operate the load, which is the fuel pump. Thank you for your attention. Thank you. Any question?